tell me how to find the vertical asymptotes.
Zeros in the denominator.
I'm asking Eric.
Yeah.
Let denominator be a 0.
Let the denominator be equal to 0. So it's x. It's x what? Eric,
Yeah.
continue. Sydney. So we want the zeros of the denominator. How do we do that?
X plus 1 equal to 0.
Right? So
X equal to -1.
x equals -1, and that's your equation for what?
That's my equation for vertical.
Right. Vertical asymptote. Right. Warren, how do I find the horizontal asymptotes?
There is none.
Why? How do I find it?
So you use your rules,
Yeah.
and like in this case, n is greater than m.
What is n?
It's like the exponent of the numerator.
And what is it in this case?
1, it's 2.
Right. Comes from here,
Yeah.
right? What's m?
M is 1,
Right.
and 2 is greater than 1, so there's no horizontal asymptote.
Right. Carlo, how do I find sine asymptote?
You gotta use long division, but it's the numerator exponent, so 2. Yeah, so it's viable in this situation.
Right, because the numerator is
the numerator
1 greater than,
Uh-huh.
yeah.
The denominator exponent.
Okay, so let's do that. Kira, how do I do long division?
So you would do x plus 1 on the outside, and then your square thing, and then x squared minus x, and then you would take your first terms, so you get x squared divided by x is x.
That's your problem?
Put that on the top,
Ish.
and then multiply out, so you get minus x squared minus x.
Multiply out and I get what?
X squared minus x squared, and then plus x. But if you distribute your negative, then you get minus x squared minus x.
Right. So this is an error that I keep finding, is people get to this stage, they find how x plus 1 goes into the polynomial the first time by looking at the first terms, dividing them out. They get an x, they put the x here, they multiply the x as they should, and then they write this here, and then they subtract like this. This is the error. If I subtract like this,
Put it under the x.
and then you're like, okay, well, I'm subtracting now, so x squared minus x squared is 0, x minus x plus x is 0. Is that right?
No.
No, what did I do wrong?
You need to distribute negative to the x also.
Right, so I have to subtract all terms, so I could do it this way, and then distribute. Or if I'm very careful, I can avoid the parentheses by just making sure that I change the sign on every single term before I add. So what is now when I add them together, what do I get?
Negative 2x.
-2x. So I'm ready to see how many times this goes into this.
Again,
So it's, how do I do that?
-2 x over x is -2.
Right, because I'm looking at the first terms only. That's -2. Where does that go?
Top. And then you
Huh?
you distribute it out again. So you're
Multiply it out again.
dividend.
Minus 2x.
Divisor. And then it's minus 2.
Sydney, stop, please.
I'm trying to get my notes.
I want you to be quiet. Go ahead, Kira.
And then you have also minus 2 as the remainder.
Minus 2. Now I subtract them. I subtract all the terms by doing what?
Distributing.
Yeah,
Negative.
yeah. So I can write the parentheses. I'm subtracting it. So I distribute by flipping all the signs. That's 0 plus 2. What's the plus 2? That's my remainder. So if I was doing long division to try to find the real answer, I would do 2 over what?
X plus 1.
Yeah, 2 over my divisor. So that's the real answer for f of x divided out equals, that's the real answer is x minus 2 plus 2 over x plus 1. But for the slant asymptote, what do I need?
Just
be a line.
X minus 2.
Right. Why is that? Why are we allowed to do that?
Equation of a line, and that's like just like a little bit of leeway.
It's a little bit of leeway, but what happens as x approaches infinity?
It'll approach 0. Maybe.
Yeah, this term goes to 0 as x gets really large. So we can ignore that term, right? So what's my equation for my slant asymptote?
X minus 2.
Right. So that's y equals x minus 2. That's my slant. Okay, so we're ready to graph. Sam, how do I graph all the things that we've found so far?
So, it's could we use Desmos?
I'm just going to graph by hand because I have some stuff that I can use so far.
Oh, okay.
What's the stuff that I can use?
2 over x plus 1.
Nope. I lied.
No, that term goes to 0 as x gets very large.
The vertical
X
asymptote.
plus 1.
Yeah. Say it again, Charlotte.
The vertical asymptote.
All the asymptotes. Let's graph all the asymptotes that we've found so far. So how do I do that?
Do the vertical line at -1 right there.
So at x is -1.
Yeah.
So
up and down.
so there's my vertical asymptote,
And you don't have a horizontal.
and I have no horizontal, so that's really easy to graph.
Mm-hmm.
Just imagine no horizontal line. Okay, what else?
Your slant
Mm-hmm.
is X minus 2.
Mm-hmm.
So it's just a diagonal line starting at
Yeah.
0 minus 2. Or, yeah, 0 plus 2.
What's the point? What point does it go through?
0, -2.
Yeah.
So if y is a function of x, and we let x be 0, that makes y -2. So 0 minus 2 would be here, right?
It's a diagonal line.
And there's just a diagonal line from there. Is it a positive slope or negative slope?
Positive.
It's positive, so it looks like this.
Mm-hmm.
Okay, and so what do we think what are the possibilities on what this could look like, Annabelle?
It's gonna
This?
look funky.
Yeah,
Well,
what's the graph look like, or what could it look like?
just with the slant asymptote.
Just with the two asymptotes. So we know we have a vertical asymptote. We know we have a slant asymptote. We know we don't have a horizontal asymptote. So what are the choices? What could this graph look like?
Well, you already have the y equals -2 and the y equals -1 going down, and then a positive 1, right? So then you have to find, so it's 2 f of x equals x minus 2 plus 2 divided by x plus 1.
I would not even look at the equation right now. just looking at these limits. So these are the boundaries. So it has to be shaped by these boundaries. So
Then it's gonna be, what's it called? It's gonna keep going up, so then you can do 0 with a slant. Right?
so what shape would it be? Kara, do you want to explain it?
Oh, well, sure.
Bless you.
Yeah, and then can I say what I was gonna say after that?
Yeah.
Okay. I think it's gonna be like a weird. It's gonna come down and then curve up in like a weird V type.
So like this.
Yeah.
So that's one way.
Do it on the other side.
And then
That's about right.
and then could it be this as well at the same time?
No.
I
No.
think it's,
No, it wouldn't be a function.
This thing right here.
Yeah, it's nothing.
Say it again.
It's the other V.
It's the other V.
Kira
All right.
knows what's up.
Okay, so that's one possibility. What's another
I
possibility?
mean, I guess it could be like a really big V going on the side.
So it could do
No,
like
that ain't
But
happening.
it doesn't
it could
look
do
right,
like
though.
this.
Yeah. That.
No, that would fit the asymptotes, but we just need to plug in some points and figure out if it's
That's
the
what I
blue
was
option or
gonna
the
say.
or the red option.
You
Blue
can
option.
find the zeros also just using the zeros of the numerator.
Okay, so just to find a point for free, it crosses the x-axis, right? So we know it's got
X-intercept.
oh, excuse me.
Y-intercept.
So if it's blue, it might cross the x-axis. So we don't know for sure yet. So if it's a blue option, it's 0, 1, or 2 crosses of the x-axis. If it's a red option, it's 2. Looks like it's got to be 2. No matter what, we're not going to be able to get away from the x-axis on the red option. So let's find our zeros, and maybe we can find out from there. Sydney, how do I find the zeros of this function?
You would set the equation equal to 0. So, wait, you said just the denominator equal to 0?
Just
Okay, just
the other one.
If you want a trick, it's not the denominator. That's how you find the denominator is how you find the vertical asymptotes. The trick is to set the numerator equal to 0.
Oh, okay.
But both
so then
work.
You
Both work.
would do 0 equals x, f of 0 equals x squared minus x. So 0.
So I'm going to do it both ways.
Like you're going to do the numerator and the
Set
denominator?
f of x equal to 0, and then I'm going to set just the numerator equal to 0 and see how we do. So this would be 0 equals x squared minus x over x plus 1, and then this would be x squared minus x, because that's the numerator, equals 0. Okay, so let's do the path on the left. Charlotte.
You multiply both sides by the thing, which equals 0, so that's just the numerator anyway.
Both sides by the thing,
The denominator.
the denominator. Okay, so let's multiply both sides by the denominator.
But is that why you just did the numerator?
Mm-hmm.
So then you would just.
So
do that.
so what do I have over here?
Then you would have x plus 1.
What's my next step? What's my next algebraic step? Amelia?
They cancel out.
You cancel out the bottom.
Cancel out the bottom?
Yeah.
What does that mean? Huh?
Okay, maybe not.
Can I just cancel out the denominator by itself?
No.
No.
You have to cancel out the other x plus 1.
Yeah, the x plus 1's cancel out.
Okay, well that's what I meant.
And then
And then you would 0 equals x squared minus x.
why is it 0 equals x squared minus x?
I don't know.
Why? Because that's what it is not a math procedure.
Because anything times 0
Hmm.
is 0.
Anything times 0 is 0 equals x squared minus x. All right, continue, Eric. And we see that we're at this step now, right? We're at the set the numerator equals to 0 step. So that's why it's a shortcut, because we could have skipped the steps if we remember that setting the numerator equal to 0 is the same as setting the function equal to 0. You see that?
Yeah.
Yeah. So Eric, let's go.
What is the next step?
What's the next step? I'm looking for zeros of the equation. We've gotten this far so far. What's next?
So x squared equal to x.
No. If this was x squared minus 9, then yeah, I would say let's do 9 equals x squared and then plus or minus 3 equals x and we're done. But that's not the case. We don't have a constant over here. We have x. So that setting x squared equal to x is not going to help me at all. What should we do instead, Sydney? Are you stretching or raising your hand?
I'm stretching.
Eric, how do I solve for x? Solve for x.
Wouldn't you just add the x to the other side? And
No,
then,
no, no. It won't help.
But then,
What does this mean?
is that it? Is that as
No.
simplified as it gets?
No, that doesn't mean that doesn't
It's
help
probably
with,
like x
that
equals
doesn't
1.
help with anything. If it were minus a constant over here, then sure, we could do it that way. Eric, how do I solve for x?
I don't know specific method. I don't know how to.
Warren, anything jumping out at
I
you?
think it's one.
Yes.
What do you do?
You can do quadratics.
You can do quadratic equation is an option here, but there's an easier method. What's the alternative method?
Factor.
Factor. Can we try to factor?
I hate
It's
factoring.
weird. I tried, but it's like
It's impos.
you.
It's not impos. Do it.
I'm not a factor
X
either.
parentheses x
I
minus
hate
1.
factoring.
X parentheses.
I hate anything.
These have a term in common, don't they? These two terms have something in common.
X.
X. So can I take out an x?
Yeah.
Yes.
And that leaves
X minus 1.
x minus 1. Is that correct? Can you distribute this back and get?
Holy crap.
When you distribute this back, do you get this?
Yeah, you do.
You do. So what does this mean? So what are my zeros?
X equals 0. X equals 1.
X equals 0 and 1.
X equals 1.
Right. You okay with that?
Yes.
It's all like making sense.
I get it.
The stars are.
So
aligned.
what is so I'm looking for ordered pairs. I have 2 zeros and I want to find out where to plot them.
0, 0.
So what is f of 0?
0, 0. Oh, 0. 0.
It's 0 because it's 0 squared minus 0 over 0 plus 1. 0 over 1. 0. So I have 0, 0. So I have the origin. That's a big clue right there. Big old clue.
Let's see.
Big old clue. And then what's my other, Sam, what's my other point that I can plot?
Is it wouldn't it be 0, 1? Or it'd be 1, 0 or something? And I know it involves.
How did you find it?
Oh. Great question. Oh, what is it?
Hmm?
So 1 squared is plus or minus 1.
1 squared. No, we're not taking the square root of anything.
Oh.
I'm
1
plugging it
squared
in.
is just 1.
Yeah.
Minus 1 is 0.
Minus 1 and then
And then you gotta do this is 1 plus 1.
1 plus 1.
So now it's 0 over 2.
So what's my point?
0, 0. Oh, 1, 0.
X is 1.
Buddy, what?
X is 1. What's f of x?
0.
Right, so 1, 0.
Yeah.
So where's 1, 0?
It would be if it would be like a little bit to the right. It would be on the x-axis. Yep.
We got a couple points. I'd say it cannot be the red option because these asymptotes do not move. The asymptotes don't move. See these moving asymptotes? They don't move.
Wonderful.
But the graph could have possibly been the red option, but it's not. It's a blue option.
Beautiful.
So let's put that in
Gorgeous.
Desmos.
Demo.
Oh, why does? Oh, never mind.
Girl, what?
You know German more, right?
How do I graph that in Desmos?
You would do y equals parenthesis or parenthesis
Parenthesis.
0, comma 0.
I can plot points. I would just put parenthesis, open parenthesis, 0, comma 0. I can plot that point. I can plot the other 1, comma 0. But I want to, in addition to the points, I want to graph the function.
X
Oh, I put a period. Meant to put a comma. Okay, so I got a couple points.
Y equals x squared minus x over x plus 1.
X squared minus x
Over
over
x plus 1.
x plus 1.
Sometimes you remind me of the sloths from Zootopia. You know what I'm saying?
Such a sweet thing to say. All right, let's do our asymptotes.
It's like in a good way because they're silly and goofy, but like.
Flash.
Let's do our asymptotes. What are our asymptotes? Where was I? Sydney,
Yes.
Annabelle, give me an asymptote. One asymptote.
Well, you just said 0, 0, 1, 0.
Those are points.
You just want me to do the asymptote?
I want pick one of the asymptotes.
Okay, I choose the first one. That's
Which
up on
is?
top. X squared. What is that? That is x minus 1. X squared. X squared minus x.
No,
X plus
that's
1.
not it.
Equations for asymptotes. Equations for asymptotes.
Are,
They're always
Y
lines.
Y
Or
equals.
x
They're always lines.
X equals.
So it would be if
No,
the
y
numerator
equals-
is if the numerator is greater than the denominator, then it's no.
You don't have to. You don't have to solve it. We've already solved it. I just want to know what to
X
write.
equals 0.
I just want to write. You should have this all written down.
X negative
I
1.
should-
Negative 1. X equals negative 1.
X equals -1.
All right, you're up for the next one, Annabelle.
Okay. I can do
They
it.
just have,
X equals -1.
it's like a light.
Make it dotted.
Yeah.
Yeah.
Okay.
X
Annabelle.
X equals -2.
X equals -2. Does that seem like it's an
No, I mean,
asymptote?
y equals -2. Sorry.
That's also wrong. Let's do y. Let's do y.
That was the slant.
Y equals -2 is not an asymptote.
But that was the slant.
No, it's not.
X minus
Go back
2.
to your notes.
Fine.
What did we figure out was the slant asymptote? Hold on. Asking
X
Annabelle.
minus 2.
I was waving the car.
Hmm?
X minus 2.
X minus 2. Look at that.
Don't do that.
So that's
Don't do
fully graphed, and we did not. So we have confirmed. Carlo,
Yeah.
can I have class, please?
Yes, sir.
So we've confirmed that this graph is correct using the powers of Desmos, but we actually just figured it out by hand. So that's without a graphing utility. We were able to find the graph. Yay!
Here, why you putting your shit?
Yay!
That's wonderful.
Yippee!
Just putting that back in. Oh god.
All right.
No.
Let's find a minimal area. Minimal area.
What the
This is exciting.
How is this related?
Because we can use our tools of math and our powers
We're
of
gonna use
mathematical
asymptotes
reasoning.
to find out what's going on.
So, a rectangular page is designed to contain. Amelia, you're pausing while I'm pausing, and then you're talking while I'm talking. Drives me
You
insane.
want me to talk in between when we talk?
I also don't want that option. No, that's the red option. Stick with the blue
That
option.
was pretty funny.
A rectangular page is designed to contain 48 square inches of print. The margins at the top and the bottom of the page are 1 inch deep. The margins on each side are 1.5 inches wide. What should the dimensions of the page be so that the least amount of paper is used?
So you have to find vertical and horizontal asymptotes.
We're actually going to find a minimum using an equation. So
Like find
let's
the limits.
finding a minimum, finding a local minimum.
Wait, what's the difference between a minimum and a limit? Because a limit is telling you how much you have before you run out. Like
A limit.
to negative infinity.
So let's go back to our other graph. So as we go as x, so I'm going to erase the red option because that could have been, but it wasn't. So here's our graph. What is the value of f of x approaching as x approaches infinity? Annabelle.
F of x as x. Okay, so that's negative 1, right?
Look at the graph. Where is the blue line going as x gets larger without bound?
Infinity.
F of x approaches infinity. That's a limit.
Oh, I was saying x. That's not what I was saying. I was saying what x equals before it can't approach infinity. Is that what a limit is?
I don't understand your question.
Okay, if you say f of x, you say x equals negative
Carla.
1, then it cannot become like the limit is negative 1.
Okay,
It can't approach
so as x approaches negative 1 from the positive side, f of x approaches
infinity. Negative infinity. Nothing. I don't know.
infinity.
I said infinity first.
Yeah, I hadn't finished writing. As x approaches negative 1 from the negative side,
It approaches negative infinity.
yeah, negative x, f of x approaches negative infinity. Whoops.
So the limit is f of x approaching infinity or negative infinity. It's not about what x equals.
Right. So as x approaches, let's just do the last one. As x approaches negative infinity, f of x approaches
Infinity. Negative infinity.
negative infinity. Right. So, right. Yeah, that's not what we're doing with this problem, but that's explaining. That is describing the bounds. That's describing the behavior of the graph as x approaches infinity, negative infinity, and any excluded x values. So if you get any questions that say, describe the behavior as x approaches any excluded values, Sam, close your iPad. Oh, you taking notes?
Yeah.
Sorry. Go ahead, Annabelle.
Well, so I watched this Khan Academy video because I was struggling with the homework, not like last night, but 2 nights before, because I didn't know what a limit was. And so every time Sal would say it, he'd be like, and as x approaches infinity, it cannot be equal to negative 1. And then I was like, is that what a limit is? Because he didn't really explain what a limit was. So every time I was doing the homework, I would just put x, if it was like going from the positive side, I would say f of x equals to the positive if it was coming from positive upward.
Right.
But if it was, even if it was a negative number and it was going this way, it's still going to infinity, because it's going the positive route. Whereas if it's a negative number and it's also going the negative route, it's also going to negative infinity. But it could be a positive number going down to negative infinity.
Okay.
Right?
Mm-hmm. Yeah, as we're seeing this, if there were a horizontal asymptote, then f of x would approach that horizontal asymptote, right?
Yeah.
Right.
Okay.
Yep.
All right. Now I know, because I just didn't know exactly what a limit was.
Sure.
I had like an idea.
Yeah. Let's look at the margins. What are the left and right margins? What's the top and bottom margins?
1 inch.
1 inch for the top and bottom.
And then the
So
sides
so
are
top and
1.5.
bottom. That's 1 inch. You okay with that notation? 1 inch.
Yep. And then the sides are 1.5.
Top and bottom are both 1 inch. Left and right are both 1.5 inches. Okay, everybody on your notes, I want you to find an equation for for the area. So let's, you need one more piece of information. Let's call this X. We'll call this Y. This is the printable area. It's the area that the printing would go on, not including the margins. So here's our printable area. Here's our margin. So I'm looking for an equation for the combined area, the total area of the page, including the orange area and the pink area. Are we at Sydney right now? Sydney, what is the overall formula for the area of a rectangle?
Wait, is the purple part 48 inches? And then the orange
Yes.
is the margins? So wouldn't it just be 48 times 2 times 3?
So
Add it.
Three minus one
If you were
plus
gonna do
two.
it that way, you would add it.
So, but like the margins, the perimeter of the margins, like excluding the purple, is
no, we're not
5.
we're not gonna find a formula for just the orange area.
Yeah,
So
but
let
the
me.
entire outside is 5 inches. Like the 2 sides and then the lengths. Total, those are 5 inches. The inside is 48. That is all I can give you. I have no idea what a unit is.
Okay,
Are you
so
supposed to
let's.
multiply those numbers?
Yes.
So-
Not those numbers. So let me describe it a little bit differently. So my area is going to be this entire. I'll still do it in purple, but I don't want to give the impression that I'm just talking about the margins. So this entire area, including the pink part. I'm going to start with a formula for the entire page. So what is the basic formula for length times width?
Length times width.
Oh no. All right, so what's the formula for area? I meant to say length times width. So what's the overall length of the entire piece of paper?
1 inch.
Overall area.
So what's the overall
What's the
length?
what's the overall length?
40.
Overall length. So we're gonna call this length.
No,
We're gonna call this width.
5.
What is it?
49.
49.5.
No.
49.
Oh,
no,
because
wait.
it's plus 3.
8.
41, 51 inches.
No.
It's gonna be 8. 8 is gonna be the
X plus 3.
X plus 3. You guys, this is a linear measure. 1 inch margin is a line. It's a
Yes, sir.
one-dimensional.
Fine, I see.
48 is a two-dimensional area. We cannot add them in any way, shape, or form. No. Warren, go. You're on fire.
Width is.
What's length?
length? Our length here is gonna be X plus 3.
X plus both of the 1.5s.
Yeah.
So if you wanted to, you could say x plus 1.5 plus x plus 1.5 equals x plus 3. What's the width, Carlo?
The width?
Yeah.
That's y plus 2.
Y plus these two 1 inch margins. Y plus 1 plus 1. So what's my area of my overall page? Eric?
X, y plus y. 5 times y plus 6.
Huh?
Yeah.
No.
No?
Length times width, my friend.
X plus 3 times y plus 2.
x plus 3 times y plus 2. Right. What's the formula, Sam, what's the formula for my printed area? The kind of red area now?
No, 1.5. Oh my god. I don't even know how to, like, I don't know.
You do. You do. So if I had just said this part, what's the area of my pink rectangle?
Hey, I don't, there's no numbers.
There's no numbers. There's no numbers. What do you have? What do you have?
Just, so x times y?
X times y. And our problem, oh, I have some undoing to do, so let me not write x times y yet. What my problem tells me that printed area, that pink area, should be what?
48 inches squared.
48.
So we have to factor and figure out what makes 48.
12 times 12. Oh wait, no, that's 145. I
Silly,
thinking
silly.
12 times 4.
So as my notability is acting up, all right, you figure out, you write down x times y equals, what's the printed area?
48 inches.
X times y equals 48. Now
And that's a small rectangle?
the small rectangle, the red rectangle, that's the printed area. The orange is the margin with no printing. So can you express the overall page in terms of just one variable? Now that you have two equations that you can use to substitute. I would like you to rewrite the equation for A in terms of just one or the other of the variables. You choose. Do you have any idea what I'm talking about?
No.
No.
I have,
Wait, let me think of it.
Amelia, what do you think?
Like factoring it?
No, we're not factoring. We are doing something that we have done on occasion many times in this class, which is come up with two different equations, so we can then express one of the equations in terms of just one variable.
What is 27 times 2?
Where are you getting 27 from?
If you,
It's like
okay,
50,
so if you,
it's like 54.
because you know x and
Wow.
y is, well,
X and y is what?
I did it wrong because it's not a square. Never
X
mind.
times y equals what?
48.
So can you express y in terms of x?
No.
48 over x.
So can you substitute in?
I like 4 times 12.
Such a good number.
I like
3 times 7.
Okay, as an exit ticket,
Make 48.
I'm going to add this on Blackboard. I want everyone to express A in terms of just one variable as a homework assignment. That's it.